For this partial project, we will solve two problems about limits and derivatives. First, we will evaluate a limit problem algebraically, which is limit x approaching to square root 6x plus 4 minus 4 over x minus 2. The first thing to do is rationalize, which means multiply the top and the bottom by what has a square root but with the opposite sign. In this case, we will multiply top and bottom by square root of 6x plus 4 plus 4. After multiplying, the result will give you square root of 6x plus 4 to the second power minus 16 over x minus 2 times square root of 6x plus 4 plus 4. The second step is to simplify the top part. Now, we can cancel the square root with the power to the second. Then we continue to simplify and add the terms, which gives us the equation 6x minus 12. We continue to simplify by taking out the common denominator. We take out the common denominator 6, which leaves the equation x minus 2 on top. Notice that now we have the same equation on the top and on the bottom. We continue simplifying by canceling these equations. When we cancel an equation like this, the product is equal to 1. Now we have the equation limit x approaching to 6 over square root of 6x plus 4 plus 4. Now that we cannot simplify any further, we must substitute the x value in the equation with the value of the limit, which is 2. Now we need to simplify completely. First, multiply 6 times 2 and add the result with the 4 inside the square root. This is equal to 16. The square root of 16 is 4, so now we add 4 plus 4. This leaves us with the fraction 6 over 8, which can still be simplified to 3/4. This gives us our final answer of limit x approaching to is 3/4. When we graph the equation, it gives us a line with a maximum point at negative 2/3, 3/2, a y-intercept at 1, and a horizontal asymptote at y equals 0.
For the second problem, it is asking me to find the slope of that tangent line at x equals 1 for the following function. The first thing we have to do is find the derivative of the function, so first we will use the derivative rules. By law of exponents, the cubic root of x becomes x raised to 1/3. Now that we simplified, we can use the rules. First, we will use the power rule of 6x over 1/3. 6x will be multiplied by the exponent of x, which will give 2. Then the exponent 1/3 will be subtracted by 1, which gives me negative 2/3. Then the power rule will be also applied for 3x. 3 times the exponent, which is 1, gives me 3. And the exponent 1 will be subtracted by 1, which gives me 0 and causes the x to disappear, leaving the 3 alone. These steps give the following equation, which leaves us as the final step to simplify the exponent. The simplification of exponents was also done by the law of exponents. Since the exponent has a negative, it will go to the other side, which will go down. And since it is a fraction, it will also turn into a root. Now that we have found the derivative, we have to find the slope of its tangent line. F of the derivative of x is equal to the slope of the tangent line. So the only thing we have to do is substitute the 1 into the equation. Doing the process, the final answer is equal to 1. So in this graph, you can find the tangent line in red, and you can clearly see that the slope is negative 1, since it goes 1 unit to the right and 1 unit down, or 1 unit up and 1 unit left.